Hi everyone, this is a fast video to tell you about how to calculate matrix determinants. I'm going to focus on 2 by 2 and 3 by 3. Okay, what is a matrix determinant? What does it mean? Well, you don't really need to know that much. What you need to know is its scalar, right? It's not a matrix, it's just a number. It has a meaning which is related to its geometry and what it does with transformations in the plane and in 3 dimensions. But that's probably beyond what most of us are going to study and research. I'll link to a video where you can learn more about that if you want to. Most important thing for us is that it helps us solve matrix equations. So it's a scalar property, single number, and it helps us solve matrix equations. The notation we use for matrix A, capital letter matrix, the determinant we use det, A, DETA, and it's with the absolute value signs, right? Those bars. Rather than brackets, it's bars. Absolute value signs. The other piece of notation you need to be aware of, or terminology you need to be aware of, is if the determinant equals 0, then we call the matrix singular. And when we do solving with matrices, you'll understand why it's called that, because there's no solution to the system of equations. But just remember, determinant equals 0, it's called singular. The other thing, we can only find determinants of square matrices. 2 by 2, 3 by 3, 7 by 7, etc. For a 2 by 2 matrix, the determinant is given by this formula. It's the first diagonal, AD, minus the second diagonal, BC. Okay, so here's 2 examples. So the determinant of 2, 1, 3, minus 2 is 2 times negative 2 minus 1 times 3. So negative 4 minus 3 is negative 7. The determinant of 15 minus 10, 8, 12 is 15 times 12 minus negative 10 times 8, which will give you 260. So for 2 by 2 determinants, that's all you need to know. Remember, AD minus BC. They might give you some more tricky questions like, if the determinant of this matrix is 7, find x. All you do is use the formula 2 times x minus 1 times 3 equals 7, and solve it nice and easily. X equals 5. They ask you if it's singular. Remember, singular means determinant equals 0. So find the determinant. 3 times negative 4 minus negative 2 times 6 equals 0. Yes, it's singular. Okay, that's 2 by 2 matrices. What about a 3 by 3 matrix? There's 2 ways you can do it. One's called minor expansion, one's the diagonal method. I'll quickly show you minor expansion, but seriously, if you're ever asked to do this without a calculator, diagonal method's the quickest. Here's minor expansion. What you think of is you take A and you cover up the row and column of A. So it's A times what's not covered up, the determinant of what's not covered up. And this little determinant is called a minor. Then you do the same thing with B. And this time it's minus B times what's not covered up. Determinant of what's not covered up. Okay, and then you do the same thing with C, and it's plus C times the determinant of what's not covered up. Okay, and then you just do the 2 by 2s. So A times E times J minus F times H, etc. And then you expand the brackets. If you want to do it algebraically, we'll expand the brackets. Okay, so that's called the minor decomposition or minor expansion. Now, it's not only with ABC you could do this. You could also do it with cover up the row and column of D, and you're left with B, C, H, J, then E, then F, or G, H, I. You have to do this plus minus thing. But if you expand that out and expand that out, you'll get the same answer as you did here. Okay, so you don't need to remember this, you need to remember how to do it. However, there's another better way to do it. This is a diagonal method. What you do is you write the matrix down twice next to each other. ABC, ABC, DEF, DEF, GHI, GHI. And you go down diagonals. So you take the first diagonal AEJ, sorry, and then you add the next diagonal BFG. Then you add the next diagonal CDH. Then you subtract the diagonals going the other way. So AFH, you subtract that. BDJ, subtract that. And CEG. So we add going from left to right and we subtract going from right to left. Or the blue we add, the red we subtract. And this little formula here is the same one we got when we did our minor expansion. Okay, so here's an example of how to use it. If I want to find this determinant, I will go 2 times 1 times 1 plus -1 times 2 times 1 plus those three multiplied together minus 2 times 2 times -1 minus -1 times 4 times 1 minus 3 times 1 times 1. And do that all together, you get your final determinant. That's how you do 3 by 3 determinants. Right. Do 4 by 4, same method. You add up those diagonals, you subtract those diagonals. So you get this. But guys, use a calculator. If your teacher's asking you to do 4 by 4s without a calculator, just being a bit mean. Learn how to do it on the calculator. You'll find a video to do that somewhere. Alright guys, good luck finding determinants. Bye.